All right, testing 1, 2, 3. Here we go. Quick thing before we get into it. I'm Javad. I used to administer the TOEFL and GRE exams in person, and for a while I was ETS Global's official preferred associate in Iran. So this isn't a theory for me. I sat across from thousands of people taking these tests, and the listening section was where I watched good students lose the most points, almost always because they hadn't listened enough beforehand. That's what this is. Just the actual lectures and conversation this test is built on. The way they actually sound with a quick note and a useful language after. Put it on in the car, put it on while you're walking, put it on doing the dishes. Don't worry if you miss something, your ear catches more than you think it does. Today, we're going to talk about an engineering lecture about one of the coolest ideas in modern design, biomimicry. Basically, what happens when engineers stop trying to beat nature and start copying it? Let's go. There's a building in Zimbabwe that's 9 stories tall. It's full of offices and shops, and for most of its history, it hasn't needed conventional air conditioning. Think about that. It's sitting in a place where temperatures can vary dramatically, yet the inside stays relatively comfortable. And the engineers didn't invent some futuristic cooling machines. They looked at something that had already solved the problem, a termite mound. That's the basic idea behind biomimicry. And once you start looking for it, you see examples everywhere. Okay, so this is an engineering lecture. We're going to start with that building in Zimbabwe, then go back to a much smaller invention, then move to one of the world's fastest trains. 3 completely different problems, 3 completely different solutions. But the same basic idea connects all of them. Nature had already figured something out. Human just had to know this. Here's the lecture. Okay, so let's start with the building. It's called Eastgate Center, and it's in Harare, Zimbabwe. It was designed in the 1990s by an architect named Mick Pierce. And one of the things that makes the building unusual is the way it handles temperature. Now, most large buildings rely heavily on air conditioning systems. You have machines cooling the air, fans moving it around, and a lot of energy being consumed in the process. The Eastgate Center takes a different approach. And the inspiration came from something you probably wouldn't expect: termites. If you've ever seen a termite mound, you might think it's basically just a pile of dirt. But inside, it's surprisingly sophisticated structure. There are tunnels, chambers, and openings that allow air to circulate through the mound. And this circulation helps regulate the temperature inside. Now, termites aren't sitting there making calculation about airflow. They don't have engineers designing ventilation systems for them. The structure itself does much of the work. Cooler air can enter lower parts of the mound, while warmer air moves upward and eventually escapes. So Pierce took inspiration from this natural system and adapted some of its principles for a much larger structure. The result was a building that could maintain relatively stable indoor temperatures while using considerably less energy for cooling than a conventional building of a similar scale. And this is where we get the term biomimicry. Biomimicry basically means using nature as a source of ideas for solving human problems. The word comes from biology and imitation. And the important thing is that you're not simply copying the appearance of something in nature, you're trying to understand how it works. That's a distinction worth remembering. If an engineer sees the shape of a bird and puts that shape on a car just because it looks interesting, That's not necessarily biomimicry. But if the engineer studies how the bird's body reduces drag and then applies that principle to a vehicle, that's much closer to the idea. And actually, one of the classic examples of biomimicry has nothing to do with architecture. It involves a dog and a very annoying walk. In the 1940s, a Swiss engineer named George went for a walk with his dog. When he came home, he noticed that the small burrs were stuck all over the dog's fur. Most people probably would have pulled them off and forgotten about them, but George became curious. Why were these little plants so good at attaching themselves to fur? So he examined one under a microscope. And he discovered that the burrs had tiny hooks that could catch onto the loops in the fabrics in animal fur. The observation eventually inspired the invention of Velcro. And that's a pretty good example of the central principle behind biomimicry. The solution wasn't invented from scratch. It was discovered through observation. Now, let's take that same idea and scale it up dramatically. We're going from a few centimeters of fabric to one of the fastest trains in the world. Japan's high-speed trains are famous for their speed and efficiency. But the early versions had a problem. Whenever one of these trains entered a tunnel at high speed, it pushed a huge amount of air in front of it. Inside the tunnel, that compressed air had nowhere to go. And when the train came out from the other side, the pressure could be released suddenly. The result was a loud, explosive sound, a kind of boom. And this wasn't just an engineering inconvenience. People living near the railway were complaining about the noise. So the engineers needed to find a way to reduce the pressure wave. One of the engineers working on the problem was Nakatsu. And Nakatsu happened to be a bird watcher. The detail turned out to be important because he started thinking about the kingfisher. Well, the kingfisher is a bird that dives from the air into the water at high speed. And when it does that, its streamlined beak allows it to enter the water with remarkably little disturbance. Now, think about the problem facing the train. The train was moving from one environment into another. The bird was doing something similar. It was moving from air into water. And Nakatsu and his team redesigned the front of the train, giving it a shape inspired by the kingfisher's beak. The result was significant. The new design reduced the pressure wave and dramatically lowered the noise. But there was another benefit. The redesigned train was also more energy efficient. So one problem produced a solution that came from somewhere completely unexpected. A bird. And this is what makes biomimicry so interesting. Nature doesn't necessarily give engineers a finished product. It gives them principles. A termite mound doesn't tell you how to build an office building. A kingfisher doesn't tell you how to build a train. And a bear doesn't give you a blueprint for Velcro. Instead, they provide a starting point. The engineers observe something that works extremely well in nature. Then they ask, why does it work? What principle is behind it? And can that principle be adapted to a completely different problem? The last word, adapted, is important because biomimicry isn't really about copying nature exactly. It's about taking something that works in one environment and modifying it so that it works like somewhere else, And nature has had an enormous amount of time to develop these solutions. Think about it. Every organism alive today is the result of an incredibly long process of variation, competition, adaptation, and survival. The vast majority of organisms that existed millions of years ago no longer exist. The ones we see today are, in a sense, survivors of that process. So, when an engineer studies a structure that has allowed an organism to survive for millions of years, they're not looking at a random design. They're looking at the result of an extremely long process of experimentation. Of course, nature isn't consciously experimenting, but through evolution, useful characteristics tend to persist while less useful ones become less common. And humans can learn from the results. That's why biomimicry is becoming increasingly important in fields ranging from architecture and transportation to material science and medicine. Researchers are studying everything from the way shark skin reduces the growth of certain microorganisms to the way plants transport water and the way geckos attach themselves to surface. The goal isn't make technology look more natural. It's to make technology work better by learning from systems that have already solved similar problems. And there's something almost humbling about that. You see, we tend to think of technological progress as a story of human inventing increasingly sophisticated things. But sometimes progress means realizing that the solution you're looking for has already been sitting in front of you, possibly for millions of years. The engineer's job isn't always to invent, sometimes it's to just notice. 5 words and phrases from the lecture that shows up constantly in academic English, TOEFL passages and IELTS Band 7 Plus speaking. You may find it like in these academic fields. To mimic, which means to copy the way something behaves, function, or looks. Like engineers can mimic biological systems to solve problems in transportation. Next word is to regulate. Well, to regulate means to control something so that it stays within a particular range or operates in a particular way. These openings help regulate the temperature inside the building. To draw inspiration from means to get an idea from something that influences the way you solve a problem. Like the engineers drew inspiration from the kingfisher's beak. Well, next word is to adapt, which means to modify something so that it works in a new situation or environment. Researchers adapted the principles found in the nature of use in modern architecture. And lastly, to scale up. It means to take an idea, process, or system and apply it on a much larger scale. The same principle can be scaled up from a small device to an entire building. And notice how useful these are outside this topic. For example, you could say, you can draw inspiration from a teacher, a book, or another culture. Or you can say you can adapt to a new environment. Or you can say you can scale up a successful business model. You can regulate your emotions, your spendings, or your sleep schedule. And you can mimic someone's pronunciation when you're learning a new language. That's what I want you to take from these episodes. Don't memorize the definitions and move on. Steal the structure. Draw inspiration from, adapt something to, scale something up, regulate. These are phrases you can actually carry into your own speaking and writing. That's biomimicry. Not the textbook definition, the way it actually sounds when someone explains it in an engineering lecture. And if you notice something about the lecture, the vocabulary wasn't necessarily the hardest part. The difficult part was following the connection. Termites led to architecture, a dog led to Velcro, a bird led to a train. And all three led back to the same idea. That's what you need to train yourself to hear. Don't just listen for words, listen for relationships. This caused that. This example illustrates that. This problem led to that solution. And this example connects back to the main idea. That's how you start following an academic lecture in real time instead of just trying to translate it sentence by sentence. So go back and listen to today's lecture one more time. No transcript, no pausing, just listen and see how much more you can catch second time. That gap between what you understand the first time and what you understand the second time, that's exactly the gap we're trying to close. I'll see you in episode 3. Keep listening.